Hello, and welcome back at UNYP Education. Savvy statisticians, data enthusiasts, gather here. It's Raffaele on UNYP Education, and today we are unlocking the secrets of confidence intervals in hopefully just about 5 minutes. Grab your coffee and let's dive into the world of statistical precision. So, what are confidence intervals? What are they? They may sound like jargon, but they're actually super useful. Imagine you're researching the effectiveness of a study technique. A confidence interval gives you a range within which you can be pretty sure the true effect lies. It's not just a single number, but a whole spectrum of possibilities. Now, how are these calculated? Well, you take your sample data, like test scores, and apply some statistical magic to examine the range of populations through mean score. The most common is the 95 confidence interval, but you can adjust this depending on how confident you want to be about your results. So, yeah. No. Can do 1% sure, sorry. Well, let's get back at 95 before Jomovi gets all angry at us. Well, alright, so how do we interpret them though? So, interpreting confidence intervals is where the real fun begins. A narrow interval means more precision, like saying I'm pretty sure that true means is right here. A wider interval, well, that's less precise, indicating more variability in your data or a smaller sample size. Let's put this into a real-world scenario. Suppose you are studying anxiety levels in university students. Weird, right? Well, your confidence interval might tell you that the average anxiety level lies between, say, 4 and 6 on a 10-point scale. This range helps you understand the accuracy of your estimate in representing the whole student population. However, we don't have only, this kind of confidence intervals. So we have many kinds of confidence intervals. So let us look, for instance, here we have like t-tests, independent t-tests, and we have confidence interval for mean difference and for effect sizes. Alright, so, first up, confidence intervals in mean differences. Picture you're comparing stress levels between two student groups. The confidence interval here will tell you the range in which the true mean difference between these groups lies. It is a powerful tool to estimate the effect of a variable, like a new teaching methods or a stress reduction program. What about effect sizes and confidence interval? This guy over, here. So, effect sizes like Cohen's d in this case, or Pearson's r, and other measures the magnitude of a phenomenon. When we calculate confidence intervals for these effect sizes, it's about understanding the precision and reliability of how large or strong this phenomenon really is. For undergraduate psychology students, here's a handy list of effect sizes you'll often use. Cohen's d, Pearson's r, or for instance we have here in ANOVA, we have theta squared. That's very useful for quantifying the variance explained by your model. So imagine you're researching the impact of therapy on well-being. So here, this is t-tests, between sample t-tests or independent sample t-tests, depends how you want to call it. Cohen's d can help you to quantify the change in well-being, while the confidence interval around this d tells you how sure you can be about this change. Does it make somehow sense? Well, I hope so. That's your quick tour of confidence intervals in mean difference, effect sizes, and, confidence intervals in general. Hopefully, it gave you a bit of percentage to your confidence. Sorry, that's jokes. These tools don't just give you numbers, they provide context and clarity to your research findings. Hit the like if you found this helpful, subscribe for more insight, and please comment down below whether you want more in-depth videos about these 5 minutes or less videos. Remember, in the world of data, precision is key, and understanding your tools makes all the difference. Until next time, keep exploring and stay curious.